Mars had always been predictable, a clockwork world of red deserts and cold precision, circling the sun with patient obedience. Every rotation, every orbit, every whisper of its thin atmosphere followed rules so old they had become a kind of comfort to those who studied it. But then something changed. A fraction of a second in its orbital period, a subtle irregularity in the telemetry, a blink in the data so faint that even the instruments hesitated to believe it. Mars, for the first time in living memory, seemed to move against its own rhythm. It began with a signal from the Mars Reconnaissance Orbiter, a reading so minor it could have been noise. Yet across multiple observatories, the same anomaly appeared. The planet's motion had deviated by a measure no natural process could easily justify. The change was microscopic, almost poetic in its precision, but in the language of celestial mechanics, even the smallest variation can echo across the fabric of time. Something had brushed against Mars, unseen and uninvited, leaving behind a tremor that rippled through equations once thought eternal. As data poured in, theories fractured. Solar, wind fluctuations, gravitational tugs, unseen asteroids, all failed to fit the pattern. Mars had blinked, and in that blink was a story waiting to be understood. In the quiet corridors of analysis, one question began to rise through the noise like a slow, gathering tide. What force had touched an entire planet, and why? Subscribe for more, because some questions deserve to be followed into the dark beneath the veil of Martian dust. A whisper began to rise, faint, mathematical, and unsettlingly precise. It came not from the surface, where rovers crawled and sampled the planet's ancient scars, but from above, in the charged quiet of the ionosphere. The Maven orbiter was the first to notice it, a low, rhythmic fluctuation in the electromagnetic field, repeating at intervals that refused to dissolve into randomness. To the untrained eye, it was static. To those who measured the invisible, it was something else, a pulse. In the days that followed, the data deepened. Across multiple orbital platforms, subtle distortions echoed through Mars' upper atmosphere. The Perseverance rover's sensors, though never designed for deep space signal work, registered faint interferences in its transmission streams, a ghostly oscillation riding on the edge of communication itself. When plotted, the rhythm revealed an eerie symmetry, as though the planet's own magnetic breath had fallen into step with an unseen drummer passing by. NASA's Deep Space Network, the vast lattice of radio dishes that listens to the cosmos, turned its ears toward Mars, expecting silence. What it found was structure. The frequencies overlapped in a way too ordered to be geological, too brief to be cosmic background, and too sustained to be dismissed as interference. Engineers scrubbed the data for errors, solar bursts, even ground-based reflections, but the pattern persisted. Each pulse arrived in intervals, synchronized with something far beyond Mars, the periapsis of 3I Atlas, the moment it swung closest to the planet before fading back into the cold beyond. To the scientific mind, this was a coincidence, an elegant, maddening coincidence. Yet coincidence, in the language of the universe, is often the seed of discovery. Some researchers speculated it could be the product of dust storms, vast enough to ionize and refract the planet's magnetic field into rhythmic distortions. Others wondered if Mars' tenuous atmosphere was amplifying electromagnetic interactions, triggered by the interstellar traveler's passage. In the vacuum of evidence, imagination filled the void, but the signal did not behave like a storm, nor like the static hum of solar interference. It was coherent, as if responding to forces that could hear themselves. Data clustering revealed a fractal-like pattern buried within the noise, a faint echo that repeated across scales. No matter how it was filtered, the pulse remained elusive, yet deliberate. Across research centers on Earth, silence filled the control rooms. The data spoke in a language no instrument could fully translate, a hum beneath the chaos, a heartbeat in the dust. Was it a natural resonance, a physical song of dust and plasma, or something that hinted, impossibly, at intention? As the red planet turned under its thin, crackling sky, the pattern endured, fading only when 3I Atlas began to drift farther away. When space hums, is it chaos, or something trying to be heard? The pattern lingered, and with it, a new unease. Patterns appear, and the mind begins to search for meaning. In the days that followed, Mars became less a planet and more a resonating instrument. The hum was faint, barely above the threshold of detection, yet it rippled through data streams like a quiet melody hidden within static. The deep space network triangulated the signal again and again, measuring its faint delay as it bounced between orbiters. Each time, it returned, altered, stretched, refracted, almost alive in its variation. The scientists who watched these distortions began to sense something profound and deeply unsettling. This was not random atmospheric chatter. It carried coherence, structure, even evolution. As though adapting to the environment that birthed it, the Maven spacecraft, orbiting in the thin edge of Mars' atmosphere, became the sentinel of this phenomenon. Its magnetometer registered fluctuations that appeared to move geographically, sliding from the poles toward the equator. Following the terminator line between day and night, the signal seemed to breathe with the planet's own rhythm, amplifying during twilight, when the upper atmosphere undergoes its brief transformation between light and darkness. Some began to speculate about coupling effects between solar radiation, dusty ionized plasma, and 3I Atlas's residual wake. Others, more hesitant, asked if it might represent something deeper, a pattern born not of the planet, but of its brief visitor. Dust storms rolled across the Martian plains during that time, great curtains of iron oxide suspended in electric tension. Lightning flickered silently in the thin air, producing static bursts that the instruments tried to disentangle from the mysterious pulse. Yet even in the heart of the storms, the rhythm persisted, measured, mathematical, indifferent to chaos. The red planet seemed to echo with something both foreign and familiar, a voice that spoke through magnetism rather than sound. At NASA's Jet Propulsion Laboratory, models were rewritten. Theorists suggested that 3I Atlas, moving at extraordinary velocity, might have induced a temporary resonance between Mars' magnetic sheath and the solar wind. Others invoked plasma physics, the possibility that the object's composition, rich in volatile compounds and exotic materials, interacted with the planet's upper layers to generate a transient electromagnetic signature. If true, it would mean that a passing interstellar traveler had briefly tuned Mars like a cosmic instrument, plucking its magnetic strings with invisible precision. As the data spread across research networks, patterns began to emerge in ways that transcended coincidence. The intervals between pulses corresponded to harmonic ratios -2 to 3, the same relationships found in the resonant orbits of moons and planets. To some, it was statistical curiosity. To others, it hinted at something that obeyed the deeper mathematics of harmony, the same language used by gravity, light, and time. And then, almost as quietly as it had begun, the signal started to fade. The last strong reading came 3 days after 3I Atlas had passed Mars' orbit, a final murmur lost beneath the dust storms that followed. Yet even after the instruments fell silent, the question lingered: was this a natural resonance, a rare alignment of forces that played out like an accidental symphony, or something else entirely? In the control rooms of Earth, the echoes of that pulse continued to haunt the graphs and simulations. Every variable that explained it seemed to unravel another layer of uncertainty. The hum had come and gone, leaving no trace but doubt, a doubt strong enough to fracture the line between coincidence and communication. And somewhere in the distance, beyond Mars and the scattered dust, 3I Atlas drifted onward, silent, dimming, and perhaps listening still. The numbers arrived first, silent, perfect, obedient, but soon they began to disobey. The telemetry from 3I Atlas came down through the deep space network in pulses of light and code, each packet a mirror of its path through the solar system. For days, everything fit the laws of celestial mechanics, gravity dictating, momentum obeying, a cosmic ballet rehearsed since time began. And then, quietly, the pattern broke. A fraction of a degree here, a delay in signal there. At first, analysts assumed error, a calibration flaw, a rounding mistake buried in the mathematics. Yet, the divergence grew. Every simulation predicted one orbit. The universe delivered another, the European Space Agency's orbital model showed a gentle curve through the ecliptic plane. NASA's Jet Propulsion Laboratory plotted a similar path, stable and precise. But the object itself refused both, like a thought unwilling to stay confined. 3I Atlas veered slightly, subtly, inexplicably. Each correction in the model pushed the error further away, as though the act of observing it distorted the outcome. 2 orbits, one physicist remarked, one real, one imagined. The data wasn't just misbehaving, it was resisting to those who remembered one eye, Oumuamua. The first interstellar visitor, the sensation was hauntingly familiar. That object, too, had accelerated without propulsion, drifting off course as though pushed by something unseen. In its wake, theories had bloomed like wildflowers in the dark. Solar radiation pressure, outgassing jets invisible to telescopes. Even in the most daring circles, the whisper of artificial design. But while Oumuamua's shape and spin had been chaotic, its anomaly could still be coaxed toward reason. 3I Atlas offered no such mercy. Its albedo, the measure of reflected light, fluctuated unpredictably. Its outgassing showed patterns inconsistent with any known cometary behavior. And most perplexing of all, its trajectory corrections seemed to coincide with observation windows. As if reacting to attention itself, the paradox deepened. In physics, anomalies are rare gifts, moments when the universe hesitates just long enough for us to glimpse its unfinished equations. Yet they also unsettle the foundation of truth. If an object moves without force, shines without reflection, and alters its course without cause, then what remains of prediction? Scientists are trained to trust evidence, but when evidence defies law, belief becomes its own uncertainty. In the conference rooms of JPL, equations sprawled across whiteboards like constellations of doubt. Analysts reran simulations under every conceivable assumption: solar-wind interference, density variation, micrometeorite impacts. None aligned. The models bent under their own corrections. Orbit lines overlapping like tangled threads in a loom no longer controlled by gravity's hand. 3I Atlas was moving with purpose, or the illusion of it. As days passed, its deviation stabilized, forming a smooth arc that carried it closer to the orbital plane of Mars. Instruments recorded faint fluctuations in reflected spectra, as though the object's surface was shifting, not melting, not fragmenting, but reconfiguring in ways that left even the most grounded physicists silent. If it was ice, it should have sublimated. If it was rock, it should have remained steady. Instead, it did both. Neither dot, and through it all lingered a question older than science itself. when data and reason no longer agree, which one bends first? For centuries, humanity has drawn its confidence from the reliability of the cosmos, the clockwork motion of planets, the predictable pull of gravity. But perhaps the stars have grown tired of being predictable in every epoch. There comes a moment when certainty fractures, when the familiar rhythm of truth stumbles into something stranger, softer, almost sentient. The researchers didn't say it aloud, but many felt it. That 3-eye atlas was not simply passing through space, but participating in it. Its trajectory seemed less like a path and more like a choice. Each subtle deviation an echo of something unseen, deliberate and impossibly aware. If that were true, then every telescope pointed toward. It was not just recording, it was being watched in return. And so, as the models failed and theories turned to silence, the question became no longer what is it, but what does it want? The pursuit of truth would demand more than mathematics now. It would demand imagination, courage, and a willingness to look beyond the comfort of the known. To chase an object that refused to obey was to challenge the very framework of reality. And in the quiet corridors of observation, one thought began to take hold. To find the truth, they would have to chase the impossible. Night after night, the tracking stations held their gaze. Across the deserts of California, the plains of Spain, and the mountains of Australia, the great antennas of the deep space network kept whispering into the dark, asking the same question: where was it now? The signals came back fractured, as though space itself had begun to stutter. Each burst of data carried with it a ghost of uncertainty, a hesitation in the numbers that no calibration could erase. The deeper they looked, the less sense it made. 3-eye atlas wasn't following gravity's script. It was writing its own. Mars, drifting in its red silence, had become an unwilling witness. Orbiters around the planet began registering faint disruptions in magnetic flux, a subtle trembling in the background hum of its ionosphere. It wasn't a storm, nor radiation, nor the pulse of solar wind. It was something between too ordered for chaos, too chaotic for signal. Maven's instruments caught the fluctuations as waveforms that repeated, then dissolved, then repeated again, almost in rhythm with 3-eye atlas's passage. Some scientists called it coincidence. Others began to sense pattern, as though Mars itself was resonating to the stranger's presence. Within the archives of planetary telemetry, analysts searched for precedents. None were found. Not during comet flybys, not during meteor swarms, not even during the intense electromagnetic storms triggered by solar flares. Whatever this was, it did not belong to Mars or to physics as they knew it. The realization grew slowly, like a shadow lengthening over reason. Perhaps the data wasn't broken at all. Perhaps it was honest. Perhaps it was describing something the models could not yet imagine. Discussions turned philosophical. In quiet conference rooms, scientists spoke less of trajectories and more of intent. Could motion itself contain information? Could a celestial body, interstellar, untouched by solar birth, carry within it a kind of encoded behavior, a resonance born of alien chemistry or geometry? To some, it was speculation. To others, it was the edge of revelation. The cosmos, they reminded themselves, had always been an instrument more than a stage. Every orbit, every vibration, every flicker of light was a form of language. Maybe 3-eye atlas was speaking, and humanity was only now learning to listen. Data scientists began reinterpreting the deviations not as random shifts, but as vectors in a hidden system. The object's motion was charted not by gravity, but by rhythm, subtle intervals of adjustment, as if maintaining a balance invisible to physics. The smallest nudges aligned with no known perturbation, not the pull of Jupiter, not solar pressure, not mass loss. It was as if it corrected itself, maintaining a trajectory of intention rather than momentum. Like a ship tacking against a current, one observer noted, it moves with the wind it creates. And yet, within this strangeness, there was beauty, a quiet defiance that mirrored the human desire to understand. In the unyielding mathematics of orbital mechanics, 3I Atlas had become an act of rebellion, a reminder that the universe is not obliged to make sense. To those watching, it wasn't just an object, it was a mirror, reflecting the limits of human certainty. As the object drifted beyond Mars's shadow, its brightness dipped, then flared, not gradually, but like a pulse. Spectrometers caught it, a clean, rhythmic flash, repeating every few hours. It could have been tumbling ice, sunlight on a rotating surface, or something else entirely, something deliberate. In that flicker, science met silence. The numbers offered no comfort, only questions. And from those questions emerged a fragile understanding that some mysteries do not wait to be solved. They wait to be seen by eyes willing to surrender the illusion of control. For the first time in years, the scientific community stood at the edge of the same emotion that once guided explorers across oceans, wonder laced with fear. The data had refused to behave, and in doing so, it had reminded humanity of its place in the cosmos, small, searching, and forever at the mercy of the unknown. The red planet turned slowly beneath the endless sky, its ochre plains and jagged highlands bathed in the faint glow of a distant sun. Dust swirled across craters, lifted by winds that whispered across valleys older than any memory. Above, orbiters swept silently, instruments tuned to the minutest tremor of electromagnetic fields and reflected light. In the midst of this precision, a single goal dominated every calculation. Track 3I Atlas as it threaded past Mars, a shadow moving too fast for human intuition to grasp. From the control rooms of NASA and ESA, two small observatories scattered across Earth. Teams adjusted sensors, recalibrated, and triangulated trajectories with painstaking care. Each command sent to a rover, each adjustment to an orbital camera, carried the weight of 100 simulations. Time stretched as engineers waited for signals to return across millions of kilometers of empty space. Each delay a reminder of the fragile connection between observer and observed. The human effort was relentless. Sleepless nights were filled with the quiet hum of computers and the low chatter of scientists comparing data across continents. Messages pinged back and forth across networks. Adjustments suggested, coordinates recalculated, models rewritten. At times, frustration mounted, instruments disagreed, algorithms faltered, and schedules collided. Yet the sense of purpose endured. Every observation, every correction, was a step closer to a truth that refused to reveal itself easily. Mars itself became a stage of motion and color. Dust storms rolled across the plains like liquid rust, reflecting sunlight in shimmering, ephemeral waves. In the polar regions, the faint glow of twilight revealed ice caps trembling under solar radiation. The thin atmosphere, only a fraction as dense as Earth's, seemed to pulse in resonance with the passage of 3I Atlas, though no one could say whether it was cause or coincidence. The planet's quiet majesty, usually a backdrop to human curiosity, now became an active participant in the chase, each rotation and tilt offering new vantage points, new moments of discovery. The object itself resisted expectation. Observations hinted at subtle structural symmetry, facets and glints that suggested uneven surfaces, perhaps angular ridges reflecting sunlight in a pattern not unlike a deliberately shaped stone. Nothing conclusive could be drawn, yet each fleeting glimpse reinforced the sense that this was not merely a comet wandering aimlessly, but something that carried within it order, however cryptic. They were chasing a rock, yet it felt like chasing intent. Instruments across the solar system worked in concert, a silent orchestra of precision. Triangulations converged, and each dataset, when layered atop the next, produced a map of motion that was part geometry, part enigma. Every anomaly, every tiny reflection, was scrutinized, measured, debated. The object's velocity, its spin, its light curves, all told a story that was never entirely consistent with expectation, yet never entirely divorced from reality. Behind the data stood minds willing to defy logic itself. Physicists, engineers, and astronomers stretched understanding, balancing known physics against the unexplainable. Mars rotated beneath them, indifferent yet intimate, carrying with it the traces of an interstellar visitor whose brief passage left questions far larger than any answer. And as the observation campaign pressed onward, one truth became undeniable. To understand what had brushed the red planet, humanity would have to chase shadows across its surface, into the thin, trembling air, and into the unknown. As 3I Atlas moved ever closer to the orbital plane of Mars, the chase intensified. Instruments that had been calibrated for decades to measure predictable motion now strained against the unusual. High-resolution spectrometers scanned for compositional signatures, capturing every reflected photon as if trying to decode a secret hidden in light. Radar and LiDAR observations probed the object's shape and rotation, revealing fleeting angles that hinted at asymmetry facets that caught the sun in unexpected ways, casting glints that suggested structure rather than randomness. Each brief reflection was catalogued, time-stamped, and cross-referenced across continents, creating a mosaic of information that was simultaneously tantalizing and incomplete. On Earth, the human element grew ever more pronounced. Researchers in cramped offices and remote observation sites fell into rhythms dictated by the orbit of two worlds, Mars spinning beneath them, 3I Atlas racing through space. Coffee cups accumulated alongside stacks of printouts. Keyboards clicked in sync with the faint hum of servers processing orbital simulations. Time became elastic, bending around the cadence of data arrivals and communication lags. A delay of even a few minutes could mean a missed observation, a lost pulse of light, a gap in the story the universe was attempting to tell. And yet, the teams persisted, driven by a mix of curiosity, awe, and the subtle fear that what they were witnessing might be beyond explanation. Mars itself seemed to respond to the chase. Dust devils spiraled across craters with new intensity, kicked up by winds the instruments recorded but could not fully explain. The planet's thin, trembling atmosphere occasionally refracted sunlight into ghostly patterns, projecting faint, shifting bands of illumination across the highlands. The ice caps, normally inert and silent, reflected morning light in slow, deliberate arcs. To those watching, the red planet had become more than a subject. It was an active participant in the unfolding event, a witness to the passage of something profoundly foreign, yet intimately connected to the physical rhythms of its own surface. Meanwhile, the data revealed anomalies that could not be easily dismissed. Light curves indicated changes in brightness inconsistent with simple rotation or surface reflection. Subtle variations in the object's spin, measured by repeated imaging, suggested that either mass was shifting internally, or external forces were influencing its course in ways standard physics struggled to explain. Each small discovery created more questions than answers. Was it merely an unusual interstellar body reacting to solar radiation, or something more deliberate? The human mind sought patterns, but the universe offered only ambiguity. Collaboration became crucial. NASA, ESA, and independent observatories shared streaming data across continents, interpreting signals in real time. Misalignments in calibration required rapid correction, and theoretical teams constructed simulations that combined gravity, radiation, pressure, and potential outgassing, yet each model diverged slightly from the others, revealing the limits of current understanding. Despite the fatigue and frustration, excitement threaded through every conversation, a quiet acknowledgement that they were tracing something remarkable, something that may never be fully understood. And then there were moments of poetic clarity, a single flare of reflected sunlight caught by a telescope in the Atacama, coinciding with a weak electromagnetic pulse measured by orbiters above Mars. No known comet or asteroid should have produced such synchronicity. It suggested an interplay between Mars and 3I Atlas, subtle, almost imperceptible, yet measurable. The scientists whispered about resonance, about the possibility of a fleeting connection between two worlds separated by millions of kilometers. A whisper in the cosmic dialogue that the instruments alone could barely capture. In these moments, the pursuit felt almost alive. It was no longer simply a matter of plotting coordinates or adjusting sensors. It became an intimate dialogue with the unknown, the object, the planet, the sensors, and the humans tracking them were bound in a delicate choreography of observation and inference. Every calculation carried emotion, every misalignment provoked reflection, and every glimpse through a telescope reminded the watchers of their own fragility in the cosmic scale. By the time the first hints of 3I Atlas's departure from Mars' vicinity emerged, a mosaic of data had formed, a record of observation, hypothesis, and human endurance. The red planet had revealed itself as more than a silent backdrop. It had become a partner in the pursuit, amplifying the subtle signatures of a visitor from the depths of interstellar space. Behind every measurement, every simulation, and every sleepless night lay a profound recognition. The chase was never just for knowledge. It was a confrontation with the limits of perception, a quiet reckoning with the possibility that some aspects of the universe act not according to chance, but with purpose. And in that recognition, the teams understood that their journey had only just begun. Behind the data stood minds willing to defy logic itself, hearts attuned to the faint resonance of Mars and its mysterious visitor, and a collective sense that the next discovery might redefine the very rules they had long taken for granted in fluorescent-lit offices and dimly lit observatories. Minds bent over screens and printed graphs, illuminated by the soft glow of numbers that refused to lie. Some were seasoned astrophysicists, their hair streaked with grey eyes, honed from decades of measuring the heavens. Others were graduate students, young and untested, yet fearless in their questioning. Across the globe, from the Jet Propulsion Laboratory to hidden observatories in Chile and the Canary Islands, they all shared a singular obsession: 3I Atlas. Too many outside the room. It was merely a fleeting interstellar visitor, an object too small and too fast to command attention. But to them, it was a test, a provocation of every assumption science had ever held sacred. Debate was constant. Some argued for restraint, cautioning against overinterpretation of anomalies that might evaporate under closer scrutiny. Others, braver, or perhaps more desperate for truth, leaned into the uncertainty, letting speculation guide inquiry rather than restrict it. Discovery has always demanded a price, one whispered, sometimes paid in ridicule. The words hung in the air like a warning. Careers could be jeopardized. Funding could be withdrawn. A single misstatement in a paper, and the world of academic rigor could turn from ally to critic in an instant. Yet the allure of the unknown was irresistible. Pulling the bold forward, graduate students pored over streams of telemetry data, tracing subtle correlations between Mars' orbital deviations and 3I Atlas's passage. Each pulse, each reflected photon, each minute variance in ionospheric readings became a clue and a puzzle that refused to submit to conventional explanation. They were searching not merely for answers, but for patterns in chaos, for meaning in the silence of space. In quiet reflection, one observer mused, "Humans search for control, yet the universe gives none. The only way to survive uncertainty is to embrace it." Senior scientists grappled with doubt in quieter ways. Even when evidence seemed to push toward anomaly, they questioned every assumption. Could instruments be wrong? Could a misalignment of calibration explain the pulses? Could a natural phenomenon, previously unrecognized, be masquerading as intent? Each hypothesis was dissected, modeled, and then tested again, a delicate dance between skepticism and wonder. And yet, the more they probed, the more the data resisted simplification. Patterns emerged where none should exist, signals repeated across time and space in ways that teased, beckoned, and provoked. At ESA, teams convened in video conferences that stretched into the early hours, translating arcane codes and complex simulations into shared understanding. Mistrust of data was frequent, caution was necessary, but so was imagination. A young scientist, bleary-eyed from observation shifts, typed a note that would circulate quickly. "It's not just a rock. It's a question we cannot ignore." The sentiment captured the growing tension between reason and revelation. To deny anomaly was safe, but to acknowledge it was dangerous. And yet, the gravity of the unknown demanded attention in these halls and observatories. Personal conflicts unfolded alongside scientific ones. Some feared ridicule in academic circles. Others worried about the political consequences of a claim that defied expectation. Yet beneath the anxiety was something deeper, a rare courage, a refusal to let conventional wisdom suffocate curiosity. Across continents and cultures, the individuals involved shared a quiet defiance, the willingness to follow evidence, wherever it might lead, even when the path seemed impossible. Amid the chaos of datasets, conference calls, and simulation errors, a subtle realization began to take hold. The anomalies were not random. Repetition hinted at structure. Irregularity hinted at intention. Fluctuation hinted at a pattern waiting to be discerned. And in that tentative emergence, the human spirit found its reflection. Amid disorder, the mind persists in seeking meaning. Every sleepless night, every argument, every discarded hypothesis contributed to the same goal, to understand something that stretched the limits of comprehension. And so, as Mars rotated beneath the observatories and 3I Atlas carved its arc across the sky, a quiet consensus began to form among those who dared to question. Patterns existed, waiting to be revealed. The whispers of intent and the echoes of anomaly were not merely instruments, artifacts. They were invitations. Amid chaos, patterns began to form, even in the quietest moments. When screens dimmed and the hum of servers faded into the background, the minds chasing 3I Atlas refused to rest. In labs across the globe, fingers hovered over keyboards, eyes tracing trajectories that shifted by fractions of a millimeter, and yet each fraction carried meaning. The object's passage was brief, fleeting, a cosmic brushstroke that threatened to disappear before comprehension could catch it. And yet, for those willing to stare into the numbers, it was alive, not with consciousness in the human sense, but with a rhythm and persistence that challenged every assumption of passivity in space. Psychology became as important as physics. Researchers confronted their own expectations, battling the instinct to normalize anomalies or dismiss subtle irregularities. Sleep-deprived teams debated endlessly whether to trust data that contradicted long-held gravitational models. In private notes, Some admitted a creeping sense of awe, tinged with fear. "It's as if the universe is daring us," one analyst wrote, "to see not what we expect, but what actually is." Others found solace in the collective struggle, the shared acknowledgement that certainty was never a prerequisite for curiosity. Amid the rigor and doubt, mentorship emerged as a quiet force. Senior scientists guided young researchers through the maze of statistical noise, calibration errors, and competing hypotheses, modeling not only analysis but resilience. They reminded their protégés that discovery often requires discomfort, that the value of observation lies as much in the questions it provokes as in the answers it provides. In late-night group calls, muted by distance and time zones, debates ranged from the technical to the philosophical. Was 3I Atlas truly anomalous, or were humans simply incapable of measuring complexity at this scale? Each discussion ended not in certainty, but in a shared commitment to pursue understanding nonetheless. The pursuit demanded collaboration, beyond borders and agencies. Data flowed from ESA's orbiters to NASA's rovers, and then to independent observatories in South Africa, India, and New Zealand. Every measurement was cross-checked, every anomaly logged and analyzed, and every discrepancy became an opportunity for insight. Even when instruments failed or signals were lost, the collective mind persisted, reconstructing fragments into a coherent, if still enigmatic, narrative. It was a choreography of intellect and patience, a testament to what humans can achieve when curiosity outweighs fear. Moments of revelation were often subtle, a spectral spike here, a faint periodicity there. Signals that would have been overlooked in routine observation now took on outsized significance. Researchers began to notice correlations between Mars' own electromagnetic fluctuations and the faint pulses associated with 3I Atlas. Nothing was conclusive, yet every hint of order, every fleeting alignment, reinforced the idea that the universe might be speaking in patterns rather than chaos. To follow these signs required imagination grounded in discipline, creativity tempered by rigor, and within this tension, the human element became inseparable from science. The researchers' passion, their sleepless vigilance, and their willingness to confront ridicule were themselves a reflection of the challenge they faced. Science was no longer a simple pursuit of fact. It was a test of resilience, of intellectual courage, of faith in observation, even when observation defied expectation. The object they tracked was distant, almost impossibly so, yet it illuminated something intimate about human nature. Our refusal to surrender to incomprehension. By the time the first hints of structural symmetry in 3I Atlas became discernible, irregular facets catching sunlight at precise angles, subtle reflections repeating with improbable regularity, the psychological landscape had shifted. Skepticism remained, but it was now tempered by wonder. The pursuit was no longer purely analytical. It had become philosophical. Could a rock from another star carry the echoes of order in a universe often thought indifferent? Could intent exist in motion itself, without life or consciousness as we understand it? As the observers continued their vigil, a quiet consensus emerged. The chase was as much about human endurance and imagination as it was about Mars or 3I Atlas. Each anomaly, each repeated pulse, each subtle deviation became a mirror reflecting the capacity of minds willing to defy logic itself. Amid the chaos, patterns began to form in the data, in the minds of those who dared to question, and in the fragile bridge between observation and understanding. And with that realization, the stage was set for the next revelation, an exploration not only of celestial mechanics, but of the hidden motifs that might lie beneath the apparent randomness of the cosmos. In the quiet of data centers, screens glowed with lines and curves that pulsed like the heartbeat of the cosmos. Trajectories were plotted, then replotted, each dataset layered atop the next to reveal alignments that seemed impossibly precise. Mars, drifting through its orbit, crossed planes of gravitational influence just as 3I Atlas brushed its vicinity. The sun's magnetic sheet, invisible yet profoundly influential, appeared to shimmer in synchrony with subtle fluctuations in the interstellar visitor's path. It was the sort of coincidence that could be dismissed by the cautious, yet its recurrence was too persistent, too structured, to be mere accident. Mathematics provided the first framework. Bode's law, a centuries-old observation about the spacing of planets, resurfaced in the modeling harmonic intervals, echoed faintly in Mars. Orbital characteristics and the transient perturbations attributed to 3I Atlas, solar tidal forces, long understood to influence planetary motion and ionized dust, offered one plausible explanation for minor fluctuations. Yet even when simulations incorporated all known forces, the patterns persisted. The deviations, alignments, and periodicities refused to vanish into statistical noise. Chaos theory, the study of how minuscule variations can produce outsized consequences, suggested that even the tiniest interstellar nudges might ripple across Mars' thin atmosphere and ionosphere. But the elegance of the recurrence hinted at more than randomness. Visualizations revealed recurring geometric motifs. When the orbital planes were projected in three-dimensional space, angles and arcs formed shapes reminiscent of sacred geometry, triangles, pentagons, and subtle spirals. Dust dispersal in Martian storms occasionally aligned with these trajectories, faintly tracing paths that seemed almost intentional, almost communicative. Ion tails from transient atmospheric events pulsed in intervals that echoed the rotations of both Mars and 3I Atlas, producing a resonance that the human eye could scarcely see, but instruments recorded with perfect fidelity. Every alignment, every echo of symmetry, provoked a quiet, almost philosophical tension in the scientists who observed it. They wrestled with the question of meaning versus mathematics. Was this pattern a manifestation of the universe's inherent tendency toward structure, a natural geometry emerging from chaos? Or was there something deeper, a hidden order, a cosmic design, or perhaps even a faint signature of intentionality embedded in motion itself? One researcher wrote in the margins of a report, "Perhaps coincidence is just physics we don't yet understand." The words carried the weight of both humility and awe, acknowledging the limits of current knowledge while leaving open the possibility that the universe could be communicating in its own language. The tension mounted as each new observation reinforced the apparent geometry. Trajectories that had seemed anomalous were now overlaid with faint harmonics. Dust plumes and ionospheric variations mapped against 3I Atlas. Passage produced recurring vectors that defied random expectation. And the sun's magnetic sheet, twisting, undulating, yet measurable, seemed to intersect the path of the visitor at intervals, so precise that the mind could only wobble between wonder and disbelief. In private conversations, debates stretched long into the night. Some insisted on natural explanation, invoking the known forces of gravity, radiation, and plasma physics. Others allowed for the uncomfortable possibility that structure could exist beyond the predictable, that the universe might fold complexity into simplicity in ways that approached intention. Every model, every graph, every spectral analysis reinforced the same paradox. The patterns were real, yet their source remained hidden, and so the researchers moved to the edge of theory, where physics, mathematics, and philosophy converged. They explored orbital harmonics not yet fully described, simulated tidal interactions across planetary and interstellar scales, and examined dust plasma coupling under extreme conditions. Every exploration deepened the mystery even as it clarified certain elements, revealing a cosmos that was at once intricate, unpredictable, and startlingly coherent. In the end, the geometry of coincidence became a mirror not just of the universe, but of the human mind seeking understanding. Each pattern, each harmonic, each fleeting alignment was a call to venture further into the unknown, to reconcile wonder with rigor, and to consider that perhaps the cosmos was whispering in a language humanity had only begun to hear. And with that realization, the path opened to speculation grounded in science, theories that would stretch the imagination and confront the limits of certainty. To explain it, they ventured into the edge of theory. The data was examined, the more intricate the patterns became. When trajectories of Mars, 3I, Atlas, and the Sun's magnetic sheet were projected over time, subtle correlations emerged that suggested a choreography too precise to be accidental. Every orbital pass, every slight deviation in velocity, traced curves that echoed one another across millions of kilometers, as if invisible strings pulled the movements into alignment. Researchers plotted these vectors repeatedly, adjusting for known forces, solar radiation pressure, gravitational perturbations from Jupiter and Saturn, and even the faint push of interplanetary dust. Each recalculation only strengthened the perception of structure. The universe seemed to be speaking in a dialect of geometry. Chaos theory offered a framework, yet even its principles struggled to account for the consistency of the alignments. Tiny changes in initial conditions can cascade unpredictably in nonlinear systems. Yet here, the deviations maintained a rhythm. It was as though the cosmos itself corrected the perturbations, guiding the interstellar visitor and Mars into configurations that suggested resonance, balance, and an uncanny echo of symmetry. Patterns appeared not only in space but across time, pulsing electromagnetic readings, dust displacement sequences, and even the faint modulation of solar wind particles passing near the Martian orbit. These were not isolated events. They recurred with a regularity that demanded attention, forcing scientists to consider possibilities beyond standard orbital mechanics. The shapes revealed in visualizations were mesmerizing. When orbital arcs were overlaid, triangles, hexagons, and spirals emerged, not perfect but unmistakably recurrent. Dust plumes on Mars traced similar curves, caught in images from orbiters and rovers, while atmospheric ions vibrated in intervals that coincided with the passage of 3I. Atlas. Spectral analysis of reflected light hinted at surface variations on the object that matched these cycles, producing an alignment between observer, planet, and interloper that seemed almost communicative. To the human mind, pattern implies intention, and scientists could not help but wonder, was the universe simply ordered beyond comprehension, or was there something more deliberate at work? The tension between mathematical models and philosophical reflection intensified. Each hypothesis challenged the limits of certainty. Was it a harmonic consequence of gravity acting across multiple scales? Or could unknown forces sculpt motion in ways current physics could not yet describe? Researchers began exploring advanced theories, orbital resonance, between interstellar objects and planetary magnetic fields, subtle plasma dust interactions, and even speculative considerations of anisotropic forces in interstellar medium. Every exploration revealed new correlations, but with them came a growing unease. The more they understood, the stranger the universe appeared. In private notes, one scientist reflected on the psychological weight of discovery. Humans seek order, yet the cosmos offers both predictability and chaos in equal measure. To witness repeated geometry in cosmic events was exhilarating, but it also unsettled the foundations of expectation. "The universe," she wrote, "is neither cruel nor kind, it simply is. And sometimes it arranges itself in ways that reflect our desire to see meaning, even when none may exist." Still, the recurring alignments defied simple dismissal, teasing a truth hidden somewhere between physics and interpretation. Collaboration across institutions became crucial. Teams from NASA, ESA, and independent astronomers compared projections of orbital harmonics, overlaid dust movement visualizations, and cross-referenced electromagnetic pulses. With each iteration, the apparent symmetry became more compelling. It was no longer a single coincidence. It was a network of correlations spanning space, time, and matter, a lattice of motion that suggested underlying principles humanity had yet to grasp. And through it all, Mars remained central, a stage and participant, its surface and atmosphere responding subtly to forces both internal and external. The planet's rotation, axial tilt, and orbital path all seemed to intersect with the motion of 3I Atlas in ways that hinted at resonance, as if the interstellar object and the red world were dancing to a rhythm that was imperceptible without careful observation. By the end of countless simulations and analyses, the line between chance and design had blurred. The geometry of coincidence was no longer merely a curiosity. It had become the language in which the cosmos whispered its secrets. And to decode those secrets, the scientists had no choice but to venture further, to explore the outer edges of theory and imagination, ready to confront explanations that straddled the boundary between the known and the almost unbelievable. Models filled screens, equations sprawled across virtual whiteboards, each line a careful attempt to explain motion that refused to conform. Some scientists insisted the answer lay in familiar physics, cometry outgassing, the gentle thrust of material evaporating under the sun's heat, nudging 3I Atlas ever so slightly. Jets of gas and dust, they argued, could account for minor deviations, fluctuations in spin, and the faint electromagnetic ripples detected near Mars. It was conservative, elegant, and comfortably within the bounds of established astrophysics. Yet, as simulations advanced, even this seemingly reasonable explanation began to strain under the weight of repeated anomalies. Other, more radical interpretations began to surface. Electromagnetic coupling between the object and Mars weak, but measurable magnetic field offered a mechanism by which motion could be subtly steered, energy exchanged, and resonance maintained. Observations of ionospheric pulses suggested interactions that could not be fully explained by gravitational mechanics alone. Scientists calculated the possible forces, each estimate smaller than the mind could intuitively grasp, yet collectively sufficient to produce measurable effects on the red planet's delicate orbit. For some, this was tantalizing evidence that natural physics could still surprise. For others, it was a whisper of something beyond conventional understanding. Then came the frontier ideas, the ones that hovered at the edge of speculation. Could 3I Atlas carry a form of propulsion unknown to humanity? Some proposed a light sail mechanism, a thin, reflective surface harnessing photons from the sun to adjust trajectory with exquisite precision. Others imagined magnetic steering systems, subtle manipulations of interplanetary plasma to nudge motion imperceptibly yet cumulatively. In some conversations, the word artificial surfaced, not carelessly, but with hesitant, almost reverent speculation. Was it technology embedded within the rock, capable of responding to its environment, or was it coincidence amplified by human imagination? A pattern-seeking mind confronting the universe's inherent unpredictability. Fringe hypotheses often sparked debate, not just among scientists, but within the larger public imagination. Alien technology, intentional guidance, self-correcting trajectories. These ideas were treated cautiously, always tethered to observation. Yet their persistence highlighted an essential truth. The measurable effect on Mars demanded explanation, and no single model fully sufficed. And in that tension, the line between rigorous science and speculative curiosity blurred, not through abandonment of reason, but through the insistence that measurement, not belief, defined reality. Philosophical reflection became unavoidable. The border between science and faith is not belief, it's measurement. When a planet shifts, even imperceptibly, under the passage of a distant object, the universe compels acknowledgement. Hypotheses, whether grounded or radical, converge on a single undeniable fact. Something acted, and it left evidence in its wake. Each model, equation, and simulation was a step along a spectrum that stretched from gravitational certainty to the far reaches of possibility. In meetings and correspondence, the debate sharpened. Traditionalists emphasized repeatable physics. Visionaries embraced the unknown with disciplined curiosity. Papers circulated, simulations cross-checked, and each new calculation pushed observers closer to a convergence point. A moment when speculation and measurement intersected with undeniable clarity. It was here, at the edge of theory, that minds could no longer rely on comfort or precedent. The data demanded engagement, demanded reconciliation between what could be known and what could be imagined. And then, quietly, almost imperceptibly, the signals began to converge. Patterns emerged that could not be dismissed by statistical noise or instrumentation error. The deviations in Mars motion, the electromagnetic fluctuations, and the subtle alignments of dust and ionized particles began to tell a story that surpassed any single hypothesis. Outgassing alone could not explain it. Electromagnetic resonance offered hints, but not totality. The speculative mechanisms, once confined to thought experiments, now seemed worthy of rigorous consideration. The realization settled slowly across the scientific community to explain this phenomenon. Every boundary of accepted physics, every fringe possibility, and every meticulous measurement had to be examined together. And just as the community began to synthesize these perspectives, the cosmos delivered its next provocation. Then came the data that no one could ignore. As the weeks unfolded, each new dataset sharpened the contours of the mystery. Mars, once thought to follow its slow, predictable path, revealed tiny but measurable deviations, subtle nudges in its orbit that resisted attribution to known forces alone. Observatories tracked these fluctuations with ever-increasing precision. Laser-ranging measurements, orbital telemetry, and high-resolution spectroscopy all contributed pieces to a puzzle that was both mechanical and, strangely, poetic in its complexity. The planet itself became a lens through which the cosmos seemed to communicate, a partner in a quiet dialogue of motion and resonance. At NASA's Jet Propulsion Laboratory, teams pored over three-dimensional orbital simulations. Every hypothetical scenario was tested. Variable mass distributions in 3I Atlas, solar wind fluctuations, even relativistic corrections to the gravitational models. None could fully reconcile the observed behavior of Mars with established physics. Each iteration brought scientists closer to a paradox. The laws of motion remained intact, yet the patterns suggested an underlying mechanism beyond the predictable interplay of gravity and radiation. In private notes, one researcher reflected, "We are watching a natural system obey the rules, yet bending them in ways that feel intentional." Speculative models gained new traction. Light sail hypotheses were refined. now incorporating subtle corrections from solar photon flux variations. Magnetic steering theories considered interactions between 3I Atlas potential charged particles and Mars' ionosphere, producing cumulative effects that could explain some of the measured deviations. Even self-correcting trajectory concepts, objects capable of autonomously adjusting motion in response to environmental feedback, were modeled mathematically, no longer purely science fiction but plausible within the margins of uncertainty. Each model, rigorous in its assumptions, teased the boundary between known science and imaginative extrapolation. Yet the human dimension remained central. Meetings stretched late into the night, voices tired but focused, debating which models merited further exploration and which required dismissal. The tension was not only scientific but deeply personal. Careers, reputations, and the credibility of entire institutions rested on the ability to interpret these measurements responsibly. Skepticism wrestled with wonder. Some scientists cautioned restraint, worried that embracing the extraordinary would erode professional rigor. Others, emboldened by repeated anomalies, argued that discipline required acknowledgement of all possibilities, however improbable. The debate itself became a reflection of the very uncertainty they were confronting, a tension between fear and curiosity, control and surrender, observation and interpretation. Observational campaigns expanded. Ground-based arrays in Chile and Hawaii coordinated with orbiters circling Mars, creating a network of unprecedented sensitivity. Small perturbations in dust motion, atmospheric density, and ionization patterns were meticulously logged. Each repeated pulse, each correlated alignment, was cross-checked against simulations of cometary outgassing, solar radiation pressure, and planetary tidal effects. When models failed to replicate the behavior of Mars under these influences, the room fell into silence, a collective acknowledgement that the universe was offering insight, but not explanation. Amid these technical efforts, philosophical reflection deepened. Scientists began to articulate a subtle but powerful truth. Understanding does not always require certainty. The universe need not reveal all at once, and patterns may exist without immediate comprehension. The border between the measurable and the imagined is porous, and human perception defines the threshold of belief. Here, speculation was not surrender but a tool, a disciplined expansion of the mind's ability to engage with phenomena that challenge expectation. Slowly, connections emerged. The deviations in Mars' orbit correlated not only with 3I Atlas passage but also with subtle oscillations in solar magnetic activity and local ionospheric dynamics. Nothing conclusive yet, but enough to suggest a resonance, a coherent interplay between the planet, the interstellar visitor, and the sun's extended magnetic influence. It was a dance of matter, energy, and force, occurring on scales both vast and minutely precise. And so, as simulations became increasingly sophisticated and models more daring, the scientific community stood at a precipice. Each hypothesis, grounded or speculative, contributed to a mosaic of understanding. No single explanation sufficed, yet together they hinted at a profound possibility that something natural, artificial, or as yet unimagined, had acted upon Mars in a measurable, undeniable way. The stage was set for revelation, for the moment when observation, speculation, and measurement would converge. Then came the data that no one could ignore, and the horizon of science itself seemed to tremble under the weight of possibility. The instruments had recorded anomalies for weeks, faint deviations in Mars' trajectory, subtle fluctuations in the planet's ionosphere, a whisper of energy in the electromagnetic readings, but it was the Maven spacecraft, tracing its high polar orbit, that captured the moment with unprecedented clarity. On a cold Martian night, as the planet rotated beneath a sky emptied of human observation, a brief plasma discharge erupted between the upper reaches of the atmosphere and the interplanetary space surrounding 3I Atlas. The event lasted only a fraction of a second, yet it carried enough energy to register unmistakably a burst of charged particles, accelerating and arcing in a pattern that defied conventional explanation. The magnitude was small by cosmic standards, yet enormous in significance. Comparable events had been seen in auroral substorms on Earth, or in the wake of solar flares interacting with planetary magnetospheres. But nothing matched the timing or specificity of this occurrence. Here was a measurable event, coinciding precisely with Mars' subtle orbital microshift, a movement that, until now, could have been dismissed as instrument noise or gravitational nuance. The plasma arc left a temporary glow in Mav's sensors, a signature that was recorded, verified, and cross-checked against independent observatories. In that fleeting moment, myth acquired mass, speculation gained form, and data became undeniable. Scientists pored over the details. The energy release, though brief, was quantifiable. Calculations suggested a transfer sufficient to nudge Mars' semi-major axis by several centimeters, infinitesimal on a planetary scale, yet astonishing for a naturally occurring, unanticipated interaction. The effect could not be reconciled with known solar wind activity or magnetic substorms alone, nor could outgassing from 3I Atlas account for the precise timing, the geometry, or the energy profile. Every hypothesis that had been debated, from cometary physics to electromagnetic resonance, now had to confront the fact of a tangible, measurable force, one that had acted on a planetary body in real time. In laboratories and control rooms, there was a hushed awe. Models were rerun, simulations recalculated, and predictions updated. Mars' path through space was no longer an abstract ellipse. It had been altered, however subtly, by a process that could be observed, timed, and measured. For a moment, the line between faith and evidence vanished, replaced by the startling clarity of a plasma flash bridging the distance between worlds. One researcher remarked in quiet disbelief, "In that flash, the distance between fact and faith vanished for a moment." Yet even as the discovery crystallized, questions multiplied. Was this a natural phenomenon previously unobserved, an exotic interaction of magnetized plasma and interstellar material? Or was it evidence of a directed influence, a subtle but precise application of force beyond any natural expectation? The data offered no definitive answer, only the undeniable reality that Mars had responded. The planet's orbit, its very motion through the solar system, had been touched in a measurable, traceable way. The implications rippled outward. Mars was no longer a distant, inert observer of interstellar passage. It had become an actor in a dialogue of energy and motion, a participant in a phenomenon that defied conventional categorization. Every instrument, every dataset, every trajectory calculation was now infused with new weight. Scientists confronted the profound realization that the cosmos could act, or perhaps communicate, in ways previously unimaginable, that forces beyond ordinary comprehension could leave traces on planets, written in the language of physics, yet resonating with poetic significance. And as MAV-N's data streamed, confirmed and reconfirmed across multiple teams, the central question loomed larger than ever. What did this mean for Mars, for humanity's understanding of the universe, for the very notion of control? The numbers had bent, reality had shifted, and the universe had offered a glimpse into a truth both fragile and awe-inspiring. But the story was far from complete. This revelation, monumental as it was, would only lead to deeper reflection about our place in the cosmos, the limits of measurement, and the fragile intersection between knowledge and wonder. The plasma event reverberated through the scientific community like a quiet earthquake. Analysts dissected every frame of data, every spike in ion density, tracing the fleeting arc across time and space with painstaking care. It was a whisper of force, almost imperceptible on a planetary scale, yet it carried consequences measurable against the precision of modern instruments. Mars, the stoic red sentinel of the solar system, had shifted a micro-movement that no known celestial mechanics had predicted, now confirmed by multiple independent sensors. Each calculation, each cross-checked dataset, reinforced the same astonishing conclusion: the event was real, precise, and temporally aligned with 3I Atlas passage. Comparisons to known phenomena offered context but no comfort. Earth's auroras, shaped by magnetic reconnection and solar wind, could flare with dramatic intensity, yet none imparted momentum to a planet's orbit. Solar flares bombarded the inner solar system with charged particles, but the resulting forces dissipated too widely to influence Mars with the subtlety observed. Even the most energetic coronal mass ejections lacked the timing precision necessary to account for the measured shift. Here, the cosmos had executed a localized, targeted interaction, a fleeting energy transfer perfectly synchronized with planetary motion. It was as if the universe had nudged the planet, with intent or design unknowable, yet undeniable. The microshift, quantified in mere centimeters along Mars' semi-major axis, became the cornerstone of every subsequent model. Simulations that had previously failed now incorporated the plasma arc as a discrete force, a single, measurable impulse acting over seconds. The recalculated orbit produced trajectories that aligned with observations to astonishing precision. Scientists marveled at the implications. Even a brief, ephemeral discharge could exert lasting influence over planetary motion when timed with perfect geometric alignment. The discovery reframed the scales at which interstellar and planetary interactions were considered significant, forcing a reconsideration of dynamics once assumed to be entirely predictable. Philosophical reflection deepened alongside scientific analysis. For decades, the solar system had been regarded as a clockwork planet obeying gravitational laws with predictable regularity. Space itself, a vacuum, indifferent to small disturbances. But here was evidence of subtle, localized intervention, a phenomenon bridging the vast emptiness between worlds and leaving tangible traces in planetary motion. Researchers confronted a paradox. The universe appeared at once mechanistic and mysterious, deterministic in one sense, yet capable of producing effects that defied expectation. The cosmos, one scientist wrote, does not speak in certainties, but in suggestions, hints embedded in motion, energy, and time. Collaborations intensified. Teams across continents reanalyzed, archived MAVEN datasets, scoured other orbiters' records, and compared readings with long-term magnetospheric observations. Each dataset provided reinforcement or nuance, revealing secondary arcs, faint echoes of ionization, and subtle electromagnetic ripples that followed similar geometric patterns. Even Mars dust activity, previously considered purely atmospheric, began to show correlations with the timing of plasma events, hinting at interactions between ionized energy, particulate matter, and planetary rotation. The planet itself seemed alive to these subtle forces, responding in ways measurable yet nearly imperceptible. A cosmic choreography recorded only by instruments sensitive enough to detect it. Amid the technical excitement, emotional and philosophical responses intertwined. Scientists were exhilarated, yet cautious, knowing the temptation to overinterpret was strong. The discovery challenged not only technical understanding but human perception of agency and scale. Here was a planet, massive and distant, affected by a brief, fleeting pulse of energy from an object passing through the solar system, a phenomenon so delicate yet so profound that it blurred the boundaries between natural occurrence and deliberate interaction. The event reframed the investigation. Mars was no longer a passive backdrop to interstellar passage. It had become a participant, a measurable witness to forces previously invisible. Every subsequent observation carried the weight of this realization, each calculation informed by the knowledge that the cosmos could act in unexpected ways, bending the numbers, shaping trajectories, and hinting at truths that hovered on the edge of comprehension. And as models, data, and reflection converged, one question eclipsed all others. What did this mean, not just for Mars, or for 3i Atlas, but for humanity's understanding of its place in a universe capable of subtle, deliberate, unmeasurable acts? The answers remained just beyond reach, poised to unfold in the contemplative silence of the reflection. The moment of revelation rippled far beyond laboratories and observatories. News outlets across the globe reported the subtle shift in Mars' orbit, the plasma arc, the inexplicable interplay of forces. Headlines teetered between sober description and sensationalist speculation, capturing imaginations and sparking debate. Across social media, diagrams and simulations circulated, each one attempting to visualize the imperceptible, to make tangible the whisper of energy that had altered a planet's path. Yet for every dramatization, there were careful voices, scientists urging restraint, reminding the world that measurement, not conjecture, defines understanding. Even as speculation spread, the core mystery remained untouched. A planet had moved under forces not fully understood. A universe had spoken in numbers, and humanity was listening. Amid the public fascination, deeper reflection emerged. Mars, glowing faintly in the twilight of distant skies, became a mirror for humanity's own longing. In its motion, its subtle responsiveness, people saw a reflection of themselves, our desire for connection, our instinct to project awareness onto the universe, our fear of isolation in the vastness of space. We project our own sentience onto the stars because we fear isolation, one commentator wrote, capturing the tension between wonder and existential humility. The red world, stoic and silent, reminded observers that the cosmos does not require meaning to exist, yet meaning can be found in observation, in inquiry, and in the persistent effort to understand. Scientific institutions responded with measured humility. Journals published meticulously peer-reviewed analyses, acknowledging both the robustness of the plasma data and the limits of current theoretical frameworks. Researchers emphasized uncertainty not as weakness, but as a necessary companion to discovery. It was a lesson as old as science itself. Progress arises not from certainty, but from grappling with the unknown, from allowing questions to expand the boundaries of understanding. The anomaly of Mars' microshift became a teaching moment, a reminder that even the most established models of planetary motion are provisional, subject to refinement, revision, or even profound reconsideration. The implications reached beyond terrestrial laboratories. Planetary science began to incorporate considerations previously relegated to speculation. The potential for interstellar objects to exert measurable influence on planetary magnetospheres, the subtle role of plasma interactions in orbital dynamics, and the resonance between cosmic bodies that might hint at principles yet unrecognized. Interstellar studies, too, expanded their scope, exploring not only the composition and origin of visitors like Three-Eye Atlas, but their capacity to interact dynamically with the planets they pass. The lines between astrophysics, planetary geophysics, and cosmic philosophy blurred, forming a richer, more intricate understanding of the solar system's choreography. Even as answers emerged, they begot further questions. Was Mars' motion truly a natural consequence of forces now glimpsed, or did it hint at a subtle orchestration in the cosmos? Could other planets, in distant orbits, experience similar interactions unnoticed, their shifts invisible to the limited precision of human instruments? And beyond the measurable, there was the unquantifiable, the sense of wonder, the humility, the awe, inspired by observing a planet respond, however minutely, to a passing interstellar traveler. In the quiet reflection following the discovery, Mars became more than a subject of observation. It became a symbol of humanity's place in a universe that is at once indifferent and intimate, vast and delicately interactive. The red world mirrored not just the motions of celestial mechanics, but the longings, questions, and introspections of those who study it. And as humanity looked upon it, a profound realization settled. Each new insight, each measured deviation, each whisper of energy carries with it a story, one that reshapes not only science, but the way we understand our own place in the cosmos. Yet even answers, it seemed, became new questions, delicate openings into further exploration, and the journey from observation to understanding was far from over. Mars had moved, the cosmos had whispered, and humanity was left to listen, to ponder, and to follow the trail of wonder wherever it might lead. The red planet, serene and distant, became a mirror in more ways than one. Across lecture halls and research centers, debates flared, not merely about the data itself, but about the meaning humans ascribed to it. Was this a one-off cosmic coincidence, a rare alignment of forces that happened to leave a measurable imprint? Or was there a subtler truth, a rhythm to the universe that had gone unnoticed until now? Philosophers, physicists, and poets alike found themselves converging in thought, each attempting to interpret the implications. In the shifting magnetosphere of Mars, in the faint pulse of plasma, they saw not only an event but a reflection of the human desire to locate patterns, to impose understanding on a reality that often defies expectation. Cultural reactions highlighted the tension between fascination and restraint. Art, literature, and media seized on Mars' subtle movement, painting it as a sign of interstellar intelligence, a cosmic signal, or even a warning. Children in classrooms traced orbits on chalkboards, imagining worlds in conversation across light years. Meanwhile, serious scientific discourse emphasized caution, reminding observers that correlation does not imply causation. Yet even within these warnings, a profound philosophical resonance remained. Mars had responded, however much, and that responsiveness compelled human reflection. The planet's microshift also inspired a reconsideration of scale and perspective. Mars, with its thin atmosphere and fragile magnetic envelope, had become a laboratory for forces that normally remain invisible. Small perturbations, previously considered negligible, revealed themselves to have measurable consequences when framed in the right context. The event forced a recalibration of assumptions about the sensitivity of planetary systems, the subtle interplay of electromagnetic forces, and the capacity of interstellar objects to act or appear to act upon worlds in ways barely perceptible yet profoundly significant. As the world absorbed these findings, discussions of humility in science deepened. Researchers repeatedly emphasized that certainty is provisional. Understanding evolves as instruments improve and theories expand. The anomaly of Mars-plasma interaction underscored the delicate balance between confidence and curiosity. Scientists acknowledged their limitations openly, embracing the uncertainty as fertile ground for discovery rather than a weakness. The lesson was stark yet subtle. To witness the universe in its full complexity requires both rigor and openness, precision and imagination. Moreover, the event sparked renewed interest in planetary and interstellar dynamics. Missions to Mars, once focused primarily on geology and atmosphere, began incorporating studies of ionospheric variability, magnetospheric responsiveness, and interplanetary plasma effects. Interstellar research, similarly, broadened its scope. Could other transient objects interact with planets in subtle but measurable ways? Could the mechanics of these interactions reveal hidden layers of cosmic architecture, patterns previously overlooked? The potential for discovery extended far beyond a single plasma arc, reaching into the very structure of how planets and interstellar objects engage across space and time. Yet amid scientific modeling and philosophical reflection, a more personal resonance persisted. Mars became a canvas on which humanity projected its longing for connection. In its measured response, in the delicate bending of its orbit, observers found a metaphor for awareness and interactivity at scales both vast and intimate. The red planet reflected not only the forces that moved it, but the desires, questions, and imaginings of those who watched. In contemplating Mars, humanity glimpsed its own need to seek meaning, to participate in the cosmic dialogue, however quietly and humbly. And so, even as answers accumulated, they yielded new questions, each more subtle and profound than the last. What other unseen forces thread through the solar system? How many micro-interactions go unnoticed, shaping worlds in silence? Could the universe itself possess an emergent intelligence, not conscious in human terms, but detectable in the patterns and responsiveness it imposes on matter? Mars, a distant, stoic observer, had reflected these questions back to humanity. The mirror was held, clear and unflinching, and the contemplation it invited stretched beyond measurement into the domain of wonder. In that reflection, one truth became undeniable: knowledge is never final, and understanding is a journey measured not solely in certainty, but in curiosity, and the courage to confront the subtle mysteries that ripple across the cosmos. Mars had moved, humanity had noticed, and in that noticing, the story of exploration, reflection, and wonder continued, reaching toward questions with no end. As 3i Atlas receded from the inner solar system, it left behind more than a trail of dust or a fleeting arc of light. It left a whisper in the paths of worlds, an echo in the measurements of instruments, and a subtle mark on the orbit of Mars. From Earth, telescopes captured its retreating glow, a pale, wandering ember against the infinite black. Mars, steadfast in its rotation and revolution, continued along its trajectory, now minutely shifted, carrying the memory of that encounter like a soft scar traced in the geometry of its orbit. There was no fanfare in the cosmos itself, no announcement, no applause, only the silent persistence of motion, indifferent and exacting, yet pregnant with implication for those who observed in the observatories and control rooms. The human response was palpable. Scientists, once constrained by certainty, now felt the thrill of uncertainty as a kind of gravity, pulling thought and imagination into new realms of possibility. The micro-shift in Mars' path was no longer merely data. It was an invitation, a demonstration that even the most colossal bodies, seemingly immutable, are susceptible to subtle, interstellar influence. Each measurement, each calculation, became a meditation on curiosity itself, on the quiet force that drives exploration, compels observation. and fuels the desire to understand what lies beyond perception. Future missions were already being conceived in the wake of 3I Atlas passage. Telescopes capable of detecting finer gravitational perturbations, probes sensitive to plasma interactions and ionospheric disturbances, and spacecraft designed to study transient interstellar objects in situ, all were now imbued with a renewed urgency. The encounter with Mars and 3I Atlas reframed priorities, transforming what was once theoretical into immediate scientific opportunity. Generations of researchers would look to this event as a fulcrum, a moment where observation, speculation, and daring measurement converged to expand the horizon of possibility. Yet beyond technical ambitions, there was a quieter, more enduring shift. Humanity had glimpsed the subtle choreography of the cosmos, the invisible threads that connect bodies across unfathomable distances. In Mars' slight orbital deviation, observers recognized a profound lesson. The universe is not a static stage, but a dynamic participant, capable of small, almost imperceptible gestures that nevertheless ripple through time and space. The cosmos, in its vastness, had spoken not with noise but with nuance, and the message was one of humility and wonder, a reminder that observation itself is an act of communion. And so, as 3I Atlas faded into the distance, and Mars continued its silent journey around the Sun, a sense of quiet awe settled. Every orbit, every deviation, every pulse of energy measured in instruments was a story, an argument for continued curiosity. To follow Mars and to watch 3I Atlas disappear was to confront the eternal question: how much of the universe remains unseen, moving in ways subtle, deliberate, or simply unnoticed? Human imagination, like a gravitational field of its own, tugged at these mysteries, drawing thought, inquiry, and aspiration into orbit around them. In the final reflection, one truth crystallized: the cosmos does not resolve its mysteries on demand, nor does it yield its secrets in full. Yet the act of watching, of measuring, of contemplating, transforms both observer and observed. Mars had moved, 3I Atlas had passed, and in their silent interaction, humanity found an opening, a space in which questions circulate endlessly, in which wonder persists without conclusion, and in which every orbit is a reason to look again. The story did not end. It continued, extending outward like the infinite paths of planets, asteroids, and interstellar wanderers, a reminder that curiosity, like the universe itself, never ceases, even as 3I Atlas drifted ever farther from the sun's warmth. The red planet's subtle deviation continued to reverberate through scientific models and philosophical thought alike. The solar system, once understood as a clockwork of predictable motion, now appeared more like a web of influence, its strands interwoven with threads invisible to the naked eye, yet palpable through the most sensitive instruments. The slight microshift in Mars' orbit, so small as to evade casual observation, became a symbol of the delicate interplay between celestial bodies and the hidden dynamics of interstellar travelers. Scientists found themselves staring at equations, simulations, and orbital projections with renewed awe, realizing that even the grand, centuries-old models of planetary mechanics could be shifted ever so slightly by transient visitors from beyond the solar system. In research centers across the globe, there was a quiet reverence. The anomalies sparked discussions that stretched long past the workday, lingering into the evening hours, punctuated by the hum of servers and the soft click of data streaming across networks. Teams dissected every parameter: plasma density, ionospheric response, the minute angular momentum change in Mars' orbit, and the precise trajectory of 3I Atlas as it moved beyond the heliosphere. Each new calculation opened the door to deeper questions. Could other planets have experienced similar subtle interactions with interstellar objects that went unnoticed for millennia? What if these microperturbations, repeated over eons, subtly influence orbital resonances, climate cycles, or even the migration of planetary atmospheres? The universe, in its vast complexity, revealed that nothing was too small to matter. The scientific implications were staggering. Planetary models were being recalibrated to account for previously unconsidered interactions, the kind that were almost imperceptible yet cumulative over time. Mars' slight displacement, though minor in absolute terms, demonstrated that even low-mass energy transfers could carry measurable consequences when aligned perfectly with planetary geometry. The fact that such an event could occur naturally or appear to challenged assumptions about orbital stability, the predictability of planetary motion, and the isolation of celestial systems. It was a reminder that the solar system, often treated as a self-contained mechanism, was in fact a porous network, subtly responsive to objects from the interstellar medium. In the quiet of data labs, astronomers whispered to one another, "The universe is more responsive than we imagined." Beyond calculations, Mars itself became a mirror of reflection. Its rust-red surface, sculpted over billions of years by dust storms, volcanism, and polar ice, now carried the memory of a passing interstellar visitor, recorded not in color or crater, but in motion. In its orbit, the planet held a story that spanned time and distance, a story of subtle communication between worlds. Philosophers and astrophysicists alike began to speak in new terms, that planets, asteroids, and comets are not merely objects of observation, but participants in a cosmic dialogue, responding to forces that humans are only beginning to perceive. In that sense, Mars had become a silent teacher, a reminder that the universe operates on scales both immense and minute, and that even the smallest deviations are imbued with significance. Artists and writers joined the conversation, inspired by the notion that a planet's path could be subtly altered by the passage of a distant object. Paintings depicted Mars as a dancer, gracefully swayed by the invisible hand of 3I Atlas. Poems spoke of the quiet intimacy of interstellar travel, of worlds conversing without voice, of trajectories that became sentences in the language of the cosmos. Even music, composed for orchestras, attempted to capture the measured pulse of plasma arcs, the subtle shifts of orbital paths, and the silent tension between deterministic mechanics and the chaos of cosmic randomness. Across disciplines, Mars' altered orbit became a symbol, a testament to both the predictability and the mystery inherent in the universe. In observatories, Mars glowed faintly beneath telescopic lenses, its red surface reflecting sunlight with stoic constancy, seemingly unbothered by the delicate changes it had undergone. Yet the instruments told another story. The energy had left its mark. Maven and Mars Odyssey recorded minor perturbations in the ionosphere, slight oscillations in magnetic fields, and traces of charged particles still lingering in regions once considered quiescent. For physicists, this became a living laboratory, a case study in planetary responsiveness. Each particle, each arc of plasma, became data points that deepened the understanding of magnetospheric interactions, interplanetary energy transfer, and the dynamics of transient objects in near-planetary space. Mars, a world long thought inert to such subtle influences, had revealed a responsiveness that challenged centuries of assumption. As researchers traced the trajectory of 3I Atlas beyond the orbit of Neptune and into the Oort cloud, they considered the broader implications. If one interstellar object could exert even the smallest influence on a planet, then countless others, passing silently over eons, might have left invisible imprints on worlds across the galaxy. What if these small nudges shaped orbital resonances, induced climate variability, or subtly guided planetary evolution? Mars became a case study not only in observation, but in the imagination of what interstellar forces could achieve. The possibility of unnoticed, cumulative interactions between stars, planets, and interstellar objects expanded the horizon of planetary science, stretching understanding to scales and subtleties previously unconsidered. Meanwhile, human curiosity became a gravitational force in its own right. Astronomers, engineers, and astrophysicists realized that each observation, each hypothesis, each simulation pulled future inquiry forward. New missions were proposed, satellites capable of mapping interplanetary plasma interactions with higher temporal resolution, orbiters designed to measure minute gravitational deviations, instruments able to detect the subtlest transfer of momentum between passing interstellar bodies and planetary magnetos. The passage of 3I Atlas had created a chain reaction of exploration, an echo of curiosity that extended far beyond the initial event. The orbit of Mars, slightly altered yet still predictable, became a reminder that observation is an act of participation, that by paying attention, humans could become part of the cosmos' unfolding story. Yet the philosophical resonance of the event extended beyond measurement. Humanity was reminded of the fragility of certainty. The universe, immense and patient, had demonstrated that even the most familiar planetary trajectories are subject to influence, and that observation alone is not sufficient to capture the full story. In Mars Microshift, there was a reflection of our own understanding, precise, powerful, yet inevitably incomplete. Scientists, philosophers, and thinkers began to speak in a shared language of humility, acknowledging that knowledge is provisional, and that every answer carries within it the seeds of further questions. Cultural discourse embraced this quiet humility. The public, fascinated by the possibility that Mars had responded to an interstellar visitor, engaged in conversations that blended awe and reflection. Documentaries, lectures, and discussions emphasized the wonder inherent in subtlety, that the cosmos does not always reveal itself in explosions, but sometimes in a faint, measurable bend of an orbit, or a fleeting flash of energy. Mars became a symbol of the delicate balance between determinism and mystery, a celestial prompt for reflection that extended far beyond scientific circles. The orbital shift itself became a metaphor for human experience, small, incremental changes that, over time, accumulate significance. Mars continued its revolution around the Sun, a steadfast sentinel with an altered path that would not be discernible without the patient scrutiny of decades of observation. It was a silent reminder that even in a universe governed by laws and constants, nuance and unpredictability exist, waiting for those with the instruments, the patience, and the curiosity to perceive them. And yet, for all the analysis, measurement, and philosophical rumination, the cosmos retained its inscrutability. The first Atlas, now a distant point of light, continued its journey beyond the heliosphere, indifferent to the humans charting its past passage. Mars, obedient to the laws of gravity, yet subtly transformed, persisted in its orbit. The solar system moved on, unhurried, vast, and eternal. Humanity, meanwhile, had been changed by what it observed. The event reinforced that mystery is not a void, but a kind of invitation, an unending prompt to seek, to measure, to imagine, and to marvel. In the silent observatories, and in the quiet of private reflection, one idea persisted. Every orbit, every micro-deviation is a story. Every subtle interaction in space carries the weight of inquiry and the potential to reshape understanding. Mars' orbit was no longer merely a path around the Sun. It had become a narrative of responsiveness, curiosity, and discovery. The red planet embodied a truth as profound as it was simple. The cosmos is dynamic, interactive, and infinitely capable of surprising those who choose to observe. For the next generation of astronomers, engineers, and planetary scientists, the passage of 3I, Atlas, and Mars' measured response became a guiding lesson. Instruments were recalibrated, mission priorities reconsidered, and theoretical models expanded to include interactions previously thought negligible. Curiosity became the lens through which the solar system was now examined, not merely as a collection of planets and debris, but as a living system of forces, interactions, and subtle communication. The cosmos had offered a demonstration of its quiet power, and humanity had listened with both rigor and awe in this new understanding. Mars' orbit became emblematic of the eternal tension between certainty and wonder. The planet would continue its silent revolution around the Sun, largely unchanged in its physical form, yet subtly altered in its path. And for those who watched, who measured, who contemplated, the meaning of the event extended far beyond numbers or graphs. It became a meditation on the nature of observation, on the interplay between knowledge and mystery, and on the endless horizon of curiosity that stretches before any species, capable of looking up and asking questions. 3I Atlas faded into the distance, yet the questions it provoked would linger indefinitely. Could other worlds, unnoticed by human eyes, experience similar interactions? Are the subtle micro-changes of planetary motion a record of countless interstellar visitors over eons waiting to be decoded? And, most profoundly, what does it mean that the universe can leave its mark in such an elegant, precise, and quiet manner? Humanity had glimpsed the edge of these questions, aware that answers are temporary companions, and that wonder, like orbit itself, is a perpetual motion without end. And so the story closes, yet never truly ends. Mars continues, tracing its path around the Sun, a steadfast observer and participant, altered but persistent. 3I Atlas recedes a distant traveler moving into the black, carrying its secrets away. The universe remains indifferent, vast and eternal. And for humanity, the orbit that never ends is not only that of planets, but of curiosity, reflection, and wonder, a cycle of observation, contemplation, and awe that will continue for generations to come. Every orbit is a story. Every deviation is a reason to look again. And in the quiet, endless dance of worlds, the invitation to wonder remains, unbroken and eternal. Even as 3I Atlas drifted outward toward the dark expanse beyond Neptune, Mars' orbit carried a subtle memory of the encounter, a whisper of interstellar influence recorded not in rock or soil, but in motion itself. Observers realized that this quiet deviation, measurable yet imperceptible without precise instruments, revealed a fundamental truth about the nature of planetary systems. They are not isolated. Each world, no matter how seemingly immutable, responds to its environment, to the currents of plasma, to the passage of interstellar travelers that sweep silently through the void. In that realization, scientists found both humility and exhilaration. The universe, vast and ancient, had quietly reminded humanity that its understanding is provisional, contingent upon observation and patience. On Mars itself, the event left no visible scar. Its surface remained sculpted by dust storms and impact craters, its polar ice caps intact, its valleys silent. Yet the planet had shifted ever so slightly in its path, a change imperceptible to the naked eye, but unmistakable in the data collected by MAVEN, Mars, Odyssey, and Perseverance. These instruments revealed that ionospheric densities fluctuated in minute pulses, that the local magnetosphere rippled with tiny waves in response to the plasma interaction, and that the planet's semi-major axis had experienced a measurable, though tiny, adjustment. To the casual observer, Mars remained unchanged. To those paying attention, it had told a story of subtle interaction across space, a story of forces and consequences normally invisible, now rendered tangible through careful observation. As teams around the globe analyzed the data, the philosophical implications became as compelling as the scientific ones. Scholars in planetary dynamics, astrobiology, and even philosophy of science debated what this encounter signified. Could such subtle interactions, repeated across eons with countless interstellar objects, have influenced the evolution of planetary systems more broadly? Was it conceivable that cumulative microperturbations played a role in stabilizing or destabilizing orbits, or in triggering atmospheric changes that could influence climate cycles over millions of years? The event forced a reconsideration of assumptions long held that planets are largely passive actors in the cosmic stage, their movements governed solely by predictable gravity. Mars had shown, in its quiet responsiveness, that the universe may operate through interactions too small to see, yet profound enough to matter. This insight reverberated in scientific planning. New missions were conceptualized with an awareness that the solar system is a more dynamic environment than previously believed. Instruments capable of tracking minute plasma interactions, sensitive magnetometers, and higher resolution orbital monitoring systems were prioritized. The microshift in Mars' path, once considered an anomaly, became a blueprint for the kinds of precision measurements that future planetary science would require. Engineers and mission planners began incorporating protocols for detecting transient, low-magnitude perturbations caused by interstellar objects, understanding that even subtle forces can accumulate into measurable effects over time. Mars became a laboratory, not just for its geology or atmosphere, but for planetary physics on the finest scales. The story of observation extended into human imagination as well. Writers, philosophers, and visual artists were drawn to the poetic resonance of the planet's subtle deviation. In literature, Mars became a metaphor for the quiet responsiveness of the universe, a world that listens, that registers, that carries memory in its orbit. Artists depicted Mars as a silent dancer, subtly guided by an unseen partner traveling from the distant reaches of interstellar space. Composers transformed data into sound, mapping orbital deviations into rhythms and melodies, creating orchestral works that echoed the interplay between Mars and Three-Eye Atlas. Across disciplines, the encounter inspired a reflection not on conquest or understanding alone, but on participation, the notion that humanity, too, is drawn into the conversation when it observes carefully, patiently, and with humility. In the laboratories, the narrative of the orbit expanded into educational outreach. Schools, planetariums, and science centers began using the Mars event as a case study to teach concepts of orbital mechanics, plasma physics, and planetary magnetospheres. Students mapped the deviations in models, calculated energy transfers, and speculated about the history of interstellar interactions in the solar system. The event became an illustration of curiosity in action, small questions leading to deeper inquiry, precise measurements revealing profound truths, and the act of observation itself as a pathway to wonder. In that sense, Mars microshift transcended data. It became a pedagogical instrument, a way to teach both science and imagination simultaneously. Meanwhile, interstellar studies were invigorated. Researchers considered that if a single object, like Three-Eye Atlas, could influence Mars so subtly, Perhaps countless other interstellar travelers have left similar imprints throughout the solar system over billions of years. Could the orbits of other planets, asteroids, or dwarf planets carry a record of these fleeting passages? Might subtle shifts in orbital resonances, previously attributed to unknown forces or stochastic variation, actually be the fingerprint of interstellar interactions? The event inspired a re-examination of historical data, of old orbital measurements, and of theoretical models, with an eye toward detecting patterns previously dismissed as noise. In this way, Mars had become both subject and guide, teaching humanity to look more closely, measure more precisely, and consider the universe's whispers as meaningful rather than random.